Deserts are dry regions of the planet with sparse vegetation and equally sparse commercial activity. They take up about 1/3 of the Earth's land surface. Roughly 2/3 of this is made up of the Antarctic desert and the Arctic, which due to their climate have limited capacity to produce vegetation that could sequester atmospheric CO2. The other third are hot deserts, which can be irrigated to facilitate the production of value-added crops for food, fuel, fiber, and to produce building materials, crops which would sequester significant quantities of CO2. The atmospheric carbon balance sheet compiled by the Soil Carbon Center of the Kansas State University demonstrates that photosynthesis is by far the best way to reduce atmospheric carbon. Annually, photosynthesis takes up 110 billion gigatons of carbon. The world has a land mass of 148 million square kilometers, of which 27.5 million are frozen. The land mass that supports vegetation is therefore 120.5 million square kilometers, from which 110 billion gigatons of carbon are taken up annually. By making the world's hot deserts, which covers 15.6 million square kilometers, capable of supporting plant life through irrigation, you could be able to sequester an additional 15.6 gigatons of carbon annually. Since 56% of this carbon is returned to the atmosphere by means of oxidation and erosion annually, the potential to sequester CO2 in irrigated deserts is 6.8 billion gigatons, which is enough to balance, if not overturn, the annual atmospheric carbon increase. Some claim this is a false hope because of the degraded soils in the desert. A hydrogen economy based on anhydrous ammonia, which is the basis of all agricultural fertilizer as an energy carrier, has a number of supporters. With fertilized deserts and revitalized phytoplankton stocks, all of which would be made possible by OTEC, there is reason to believe the greenhouse problem can be surmounted. This would be a win-win for developing nations as well as the developed. The former would gain agricultural and economic benefits, and the latter would be spared the ravages rising seas will work on their coastal infrastructures. Ocean waters and marine sediments have also been proposed as repositories for excess atmospheric carbon, but the dissolved CO2 produces carbonic acid, which is detrimental to the shells of calcifying oceanic organisms, which in turn would inhibit their ability to take up CO2. Central pivot irrigation is a form of overhead sprinkler irrigation commonly used in desert irrigation. Plants grow by the fundamental process of photosynthesis, the chemical formula for which is water plus carbon dioxide plus radiant energy equals sugar. One definition of a desert is an area that receives average annual precipitation of less than a quarter meter, or an area in which more water is lost to evaporation than falls as precipitation. Hot deserts usually have a large diurnal and seasonal temperature range with high daytime temperatures and low nighttime temperatures due to extremely low humidity. Hot deserts in the daytime reach temperatures as high as 45 degrees centigrade in the summer and dip to 0 or lower in the winter. Water acts to trap infrared radiation from both the sun and the ground, so dry desert air is incapable of blocking sunlight during the day or trapping heat during the night. During daylight, most of the sun's heat reaches the desert floor, and as soon as the sun sets, the deserts cool quickly by radiating its heat back into space. Neither of these conditions are conducive to plant life. They would be mitigated, however, by irrigation.